like state operated check.
All right, 1.8, if you notice, okay, yesterday we talked about domain. Remember that?
Yes.
Okay, where's the domain come from? The D&D, Dungeons and Dragons. Domain and denominator. Good job, so.
Oh, really?
Okay. Oh my gosh. Okay, so today we're talking, we're gonna add more pieces to the puzzle. So if you look at like what these are going to be asking you, they're gonna ask you for the domain, the wholes, the zeros, the vertical asymptotes, the horizontal asymptotes, the y-intercept, all based off of just an equation, okay? So first we have zeros, okay? And I told you that they come from the domain, right? Sometimes though, like in this instance, you can't tell because, can I factor that? Can I factor that? Well, kind of, but you get like this ugly, and then what is that? If I minused 2 and took the square root, what would that be? 2, how many, 2 what? 2, what's the square root of a negative number?
Positive?
If I just set this equal to 0, and I got the square root of negative 2, what's the square root? Yes, imaginary. They're imaginary or non-real answers. Remember, you have 2 non-reals. So, hey. So, this graph, see this weird looking graph? I have 2 real zeros, don't I? These zeros, and I have 2 non-real zeros. So my real zeros are here and here. Do you guys see those? Okay. But then my zeros are -4 and 2. And where did those come from? Can you tell? Look at this. They come from the graph. Yep.
From the top part.
Numerator. Yes. If I were to factor this, that's where the zeros come from. So when I'm doing my domain, Michael and Capri. Oh, sorry. Sorry. So if I want my domain, if I look at the denominator and it's nothing, okay, then you're going to have to look at your graph. So what would my domain be just from this graph? Well, no, domain is your x. So if I was walking, okay, and I go this way, I'm going from negative infinity to positive infinity. Who said that? Huh?
Like you can't just say all reals next.
You could say all reals, yeah, but I'm just doing it in interval notation. Yeah, all reals is fine too.
So your interval notation is always what's going to be used on the AP test, right?
Yeah,
Okay.
yep. That's a really good question. But they can't mark you off if you write all real numbers, can they? Like it's exactly the same, unless it specifically says use interval notation.
All right.
So you would still get points for that. Yeah.
So if you're finding the zeros, you would look at the bottom, and then if the bottom doesn't work, you would go to the top.
No. When you're finding the domain, that is the bottom. The zeros are always from the top. Because think about it logically. Okay? If in my calculator I have a 0 in the top of an equation, does that work? Like 0 over 8. Will I get an answer? Yes, I get 0. I can have a 0 in the top. That is okay. Can I have a 0 in the bottom? No, that's the one where it's like, so if you think about it, zeros can't come from the bottom because they're undefined. Hence, they're asymptotes. Hence, that's where the domain comes from, because that's what tells you where to stop and start again, because those are asymptotes. But zeros really don't affect my domain, do they? Because it's just where it's hitting the x-axis, okay? Weird, kind of. Here's another really weird thing, okay? There are these things called holes. Now, I have noticed for the past couple years, some kids' calculators show them and some do not. And I Googled it, like why do they show up and why do they not? And there's no real answer. It's just the pixels in your calculator for some weird answer. I don't know why. Okay? So, first step you're going to want to do is factor. So try and factor that. Can you factor the top and the bottom? Yeah? Henrik, do you have a pass or just with somebody?
I just like walk to the office and goes in there and like does like the notes, so I just kind of just like walk.
Okay. Do you walk to the office?
But yeah, I went through office. but it's
Oh.
not here, so.
Oh, perfect.
The girl
Okay.
was there, so-
Mrs. New?
No, I don't think it was this.
Oh.
Yeah.
Cool.
Yeah, there was one that
Yeah, that gives out the passes.
yeah.
Wasn't it last year that they were doing like, remember when you got the little printed one at the end of the year?
Oh, the receipt.
Yeah, the receipt. Where's that? I wonder where we're not, she does that?
Yeah.
I haven't seen one yet. What is this? -4 plus 3?
Yeah.
-4 plus 3. Okay, so do you notice how there's an x minus 4 and an x minus 4? There's one on the top and one on the bottom. So do you remember that from Algebra 2? What do we do with those? Cross them out. Those also become a whole. That is your whole. So a whole definition is when you have a factor on the top and a factor on the bottom that can cross off, okay? Those are a whole. So I'm going to have a whole at x equals 4. When I go to put this in, y equals, if I have x squared minus x minus 12 over x minus 4. When I go to Zoom 6 and I graph it, look what happens. Why is that giving me a straight line, do you think?
Because it's just x plus 3.
Yes, fantastic. Because that's all I have left, right? I crossed these out, so I've simplified my equation, and it's just giving me a linear line. I have tried to zoom in at 4, and it does not show the whole. So if you zoom way in at 4, it does not show the whole. However, it does show it when you go to the table. So look at the table. So that right there, it's not an asymptote because it's not like splitting down and your graph is like going in both directions. It's not an asymptote. It's just a spot that it skips over and it's a hole. Okay? So if I want to graph this, 3 and -3 are my two dots. And then I would graph this like this, 1, 2, 3, and then I put a hole like that, is what it kind of looks like. So all that means is you can't have 4, because if I divide by 0, I would get an error, wouldn't I? And that's the only thing in the denominator. So that's the only number that doesn't work. So that's where that hole comes from, by canceling both of those. So then, what's my domain? As you go from left to right on the x, I'm going to go from -infinity to what?
4.
4, fantastic. And then 4 to infinity. And 4 is not included because it's a whole, and it was like drop off. You'll see it like on the next page, like they will point out, a hole will be see that little hole? Okay, it'll be very obvious if there is one, okay? But it's not obvious on your graph, so sometimes this isn't always the best thing, is it? Okay? but you're gonna be able to see it if you cross them out, or if you go to the table and you have an error. Does that make sense? Hopefully, okay. And then what's my 0? -3. You will notice on the homework, they also call these, do you guys know other names for zeros? X-intercept, fantastic. It could also be an X-intercept. Or they call them a root. So there are other names. Okay? Just know, like, you'll see on the homework tonight, for number 10 and 11, they list them as X-intercepts here and roots here. Those are just your zeros, okay? Okay, so zeros. It's kind of what we just talked about. When you're dividing two fractions where n and d have no common factors, okay, the zeros of the rational function occur at 0. So if they have no common factors. So that's like this one. So let's factor this. What do we get when we factor this? 4 times x plus 2, x plus 5, and x minus 2. So, my domain comes from the denominator. So this is how I remember it. You have to kind of try and come up with some memory techniques because there's a bunch of things you have to remember. Like, where do I get the vertical asymptote? Where do I get the horizontal asymptote? Where do I get this? Da, 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 da. There's just a lot of things that kind of flood your brain, okay? So the domain comes from the denominator. So I'm going to go from negative infinity to -5, right? -5. Union, and then -5 goes to +2. Union, and then 2 to infinity. Huh?
You said to infinity.
To infinity and beyond. Okay? And then is there a hole? No, because I did not cross them out. Doesn't it kind of look like this would be a hole? Okay? But there isn't because I didn't cross anything out. You guys awake? I feel like you're out of it. Shut up. What is the 0? Where does that come from? Comes from the numerator. X equals -2, which is right here. Right? Okay? And then last but not least, the vertical asymptotes. Okay, so do you remember yesterday we did horizontal asymptotes? Yeah? Okay? So yesterday we did these. And you can either have, there's only 3 choices, and you divide the leading coefficients. So that's for horizontal. Okay? You divide the leading coefficients for horizontal. So for vertical, these are going to be, if you look at them, where do they come from? The denominator again. Because essentially, if you think about it, you're dividing by 0. And you can't divide by 0, so that's why you get this blank empty space. Okay? For the vertical. So that's your denominators. So x is -5 and x equals 2 are your vertical asymptotes. So there's a couple new little things. Okay, so let's try this one. So if you look on the back, example 4, they give me the equation, and example 5, they give me a graph. So try to fill in what you can for the first one, for number 4. Okay, so did you guys factor it? Okay, so what'd you put the top?
X plus 3x.
X plus 3, x minus 3. Fantastic. Did you already get one?
Yeah.
And then the bottom, x minus 3, x plus 1. Is that right? Okay, so that's always my first step. I mean, you can do whatever, but I feel like that helps me see what the domain is, and it helps me kind of fill in everything else, because those are kind of the numbers you're using, aren't they? Really, if you think about it. So the domain comes from the denominator. So then I'm going to be, my answers are 3, or my zeros are at 3 at -1, so I could put those in. 3 and -1. And then, so,
Wait, so you
I'd love the zeros.
hold on, just hold on. So we have to do it, okay? You have, for the domain, okay? For this domain, we have to use 3 and -1. So I'm going to go -infinity to -1. -1 to 3. I love that you guys are. And then 3 to infinity. But then, yes, what do you notice?
There's a hole.
There's a hole. I said there's a hole in my boot, but that's wrong, isn't it? It's supposed to be snake. Isn't it snake? Yeah. There's a snake in my boot. Okay, so, when you do this, if I cross out -3 and x minus 3 and x minus 3, that is a hole. So when I list my hole, that's going to be at 3. Okay? Oh, that's what you were saying I did wrong. Duh. That's not there. That's the next one down, isn't it? I put it in the wrong spot. So x equals 3 is my hole. And then my vertical asymptotes would normally be 3 and -1, right? X equals 3 and x equals -1 because they're vertical asymptotes. But this is a hole, so you don't include that in the vertical asymptote. But normally, if those didn't cancel out, you would include both of these as your vertical asymptotes. Does that make sense? Okay? But since it's a hole, you have to move that one up to there because you canceled both of them out. So it's just x equals 1. Making sense, kinda?
Wait, why is it not -1?
Oh, it is. So what is your zeros then? Huh? Fantastic. Remember your zeros come from the top. So x equals -3. And if this wasn't canceled out, it would also be +3. Okay, but it's canceled out, so it's a hole, so that doesn't go there. And then your horizontal asymptote. Do you remember? That's from yesterday. So how do I do that?
X squared.
You are on it, yes. X squared divided by x squared. Remember, that's the horizontal asymptote. So vertical asymptote comes from the bottom. Okay, those are kind of like where you drop off the cliff. And then horizontal asymptote, you are canceling those out. So what does that mean? Yes, fantastic. Y equals 1. Now, y-intercept, how do I get that? How'd you get that?
You plug in 0 for x.
Fantastic. We kind of talked about that yesterday, didn't we? Where to get your y-intercept, you essentially want to put a number there, don't you? You want to put a number in the y spot. So if I want to put a number in the y spot, I have to put 0 in for x. So somebody was like, can I use the ones in pink? You could totally use the ones in pink and you'll still get the same answer. Because 0 plus 3 is 3, and 0 plus 1 is 1, and 3 divided by 1 is 3. I always just go back to the original equation and put 0 in, but it doesn't matter. Because 0 squared is 0, minus 9 is -9. And then 0 minus 0, I'm just putting 0 in for x, and then minus 3 equals 3. So that is your y-intercept. We feeling good? Kinda, sorta? Yeah? Okay, so try the next one. It's a little bit different. You got a whole. And you got a domain. And you got a vertical asymptote, don't we? And we have two zeros. So anybody want to do the domain for Jolly Rancher? Have we already, yeah, Capri?
Negative infinity to -4.
Perfect.
-4 to 7.
Perfect.
U 7 to infinity.
Perfect. Yes. Did you want blue?
No, sure is good too.
Okay. Where's the hole? You can obviously see it. 7. So that means the top of this equation is an x minus 7 divided by an x minus 7. We have no idea what it is, okay? I'm kind of just saying that because they both would cancel out, and that's where this hole comes from, okay? And then what are my zeros? X equals -2 and 2. Is that you, Erilyn, too?
Yeah, and someone's there too.
And Miriam. But Miriam already got one, didn't you? Or was that Isabel?
I am.
Did you get one, Isabel?
She didn't say anything.
But I think you have, haven't you?
Yeah.
Did I miss you? Sorry, self.
It's okay.
Vertical asymptote. So there's only one. Okay? So vertical asymptote is x equals -4. Is that right? -4. So where would that go? Yeah, why? You're right. 100%. Because you're dividing by 0 at this point, and that's impossible. That's where this comes from. Why it's even there is because you can't divide by 0. Like, it's literally impossible. What would it be? X plus 4? Okay. Horizontal asymptote. It looks like there's one there, doesn't it? Like in the middle? Looks like there would be like 4. You see them? Like here. This is kind of what was weird yesterday. So, horizontal asymptote is when these two are pushed more together and they're both going towards the same number. So this is one where there's none. There's not a horizontal asymptote because those are not going to a number, are they? They are both going up into infinity. So these are both going to infinity. So they're not going to a number. So if you remember yesterday when we talked about that, it would be like this, where the equation, it has an x on the top and a number on the bottom, and there's no horizontal asymptote because they're not narrowing down. They'd have to be like straightened out and come together to narrow down to one line. So this is a none. And then what's your estimate for the y-intercept?
-0.1.
-0. Yeah. I said 2.5, but it can be, yeah, any of those. It just says estimate, so whatever. A quarter? I don't know. Okay, last but not least, I want to just talk about this real quick and show you how easy it is. We're not really going to use it yet, but we will in the future. Okay? So a sine table. What does the word sine mean in math?
The little alligator mouths.
No, those are inequalities.
Like plus, minus.
Sine. A sign. Positive and negative, right? Huh? Signs, signs, everywhere the signs. You know that song? No? I sing a lot of songs from my high school, and you guys are like, whatever. That was 25 years ago. Crazy lady. Okay, so signs. Is it positive or negative? Okay? So Pretend you're like walking along the x-axis. Here's my little guy, and I'm walking along the x-axis. So I'm gonna start at negative infinity and go to 4. Where is the function? Positive or negative? Negative. It's down below the x-axis. It would be, my answers, think about it, my answers would all be negative, wouldn't they? When they come out? Because I went over negative and down, like they're negative answers. What would be negative 4? When I got to negative 4, what would happen? It would be undefined. There's nothing there. That's a gaping hole, okay, that I would have to jump over. And then what happens from negative 4 to 2, like this little window?
It's
Positive, fantastic. What's at negative 2? Because it's
Zero.
above the x-axis.
0.
Just this chunk, Bryce.
Oh,
This is 0, negative 2 is 0. Then what happens here?
Negative.
It goes negative,
and it's 0.
and then it's 0 again. You with me? This is pretty, hopefully, kind of easy. I think you're probably overthinking it.
Yeah, I didn't know
Yeah.
about the graph.
Yeah, we're just looking at the graph, and is it above the x or below the x? Positive or negative? That's it. From 2 to 7, positive. 7 is undefined, and then it's positive. All right, that is it, my friends.
Oh, no. That's really good.